Hello, this is Mr. Huber. In this lesson, we're going to work on solving quadratic equations using factoring and graphing. Factoring quadratics and graphing quadratics are skills that we've worked on. Now we're going to see where we can apply them to be able to solve quadratic equations. So first we're going to talk about factoring. Okay? If we want to solve a quadratic equation by factoring, these are some steps that we can follow. The first thing we need to make sure we do is that our equation is set equal to 0. Then we need to factor the quadratic part of the equation, and then we're going to take each of those factors and set them equal to 0 to solve and get whatever solutions we might have, and we can check our solutions. Keep in mind as we go through that if you're solving a quadratic equation and finding solutions, that's the same thing as finding its zeros or its roots. Okay, we'll talk about zeros. Sometimes we could be asked to find the zeros of an equation. That's the same as being asked to find the solutions of the equation. So we're going to do some examples here. Right? If we want to solve this equation, x squared minus 10x plus 21 equals 0, you'll notice it's already set equal to 0. So now we've got this left side of the equation here that we can factor. So if we factor this part of the equation, right, that's going to be x minus 7 and x minus 3 equals 0. And now we set each of these factors equal to 0. X minus 7 equals 0. X minus 3 equals 0. And the reason we do that is if we can get this part of the equation to be equal to 0, when we multiply by this part of the equation, we're going to end up with 0. 0 in this parentheses times anything over here will come out to 0. And same here, if we can get x minus 3 to be equal to 0, whatever makes this factor equal to 0, when we multiply, the whole solution product will be 0. Right? If either factor when you're multiplying is 0, you'll always end up with 0 when you multiply. So we can figure out when either of these factors are equal to 0 to get our solutions that will make this equation true. So in the first part of that, if we add 7 to both sides, we get x equals 7. And then if we add 3 to both sides, we get x equals 3. Those are our two solutions for the equation. And again, we can check them. We can take 7, we can plug it back up in here to the original equation. We can work out this left side, and it should come out to 0 equals 0. Same with 3. We plug 3 in here, we get 3 squared. Let's try that would be 9. So if I plug 3 in, I'll get 3 squared minus 10 times 3 plus 21. That's 9 minus 30 plus 21. That's 0 equals 0. That checks. When I take this x value of 3 and plug it into the equation, it makes this a true statement. And we could do the same for 7 and plug it in as well. So be aware, at the end you can check your solutions to make sure they are working. Right? Now let's talk about solving a quadratic equation by graphing. We can use the graphing calculator to do this effectively, or some other graphing tool. We want to make sure the equation is set equal to 0, again, or that it's a y equals or f of x equals equation. Then we can graph it and find the x-intercepts. X-intercepts are the points where the graph crosses the x-axis, where there's a y value of 0, and again we can check those solutions. So I'm going to show you what that would look like, and I'm going to show you what the calculator screens should look like so you can practice this on your calculator and make sure that you're getting the process down properly. Okay? So this equation here, x squared minus 10x plus 21, we're trying to solve it. This is the same equation we had before, so let's solve this same one by graphing. So it's set equal to 0, so I'm going to enter into my y equals screen on my calculator the equation. You'll notice down here, these are the buttons that were pushed to be able to go through these steps. So we're going to enter our y equals, and then you can see we do x squared minus 10x plus 21. So these are the buttons you can follow to make sure you've got your equation entered correctly. Once we enter the equation correctly, then we press graph, and we want to zoom to a standard window. So if your window is off and you don't see your parabola on the graph, you may need to press zoom, okay, the zoom button right here, and then 6 for zoom standard. And that gives you a window from -10 to 10 on both the x-axis and here on the y-axis. Sometimes that will be what you need to then be able to see your parabola. Okay? And to be able to solve this now, we're looking for these 2 points, right here and right here. Again, those are the zeros. Those are the points on the graph where the y value is equal to 0. This would be something comma 0, something comma 0. And that's why they're called the zeros as well as the solutions. So if you're asked to find solutions or zeros, those are the points you're looking for. So how can we do that? Well, I'm glad you asked. To find the x-intercepts, these are the steps we're going to follow. Again, we can follow along here with the buttons that were pushed. Press second and trace for calculate. Okay. In that calculate menu, you're going to see the second option is zeros. You're going to calculate the zeros. Okay. So to calculate the zeros, you're going to be asked to enter a left boundary and a right boundary. You don't see them on the screen, but when you're doing it on your calculator, you're going to see where you're going to need to enter a left boundary. So you're going to pick any point kind of in this area, and it's going to enter a left boundary. Then you're going to go to the right of this zero. You're trying to find the zero, so we set a boundary on its left side. Now we need to set a boundary on its right side. And it doesn't matter where on the right side. As long as you set some boundary, you put the cursor to somewhere on the right of that, enter, and now you've got your left and right boundary. You're going to be finding a zero that's between these two boundaries. So you're going to be finding this point right here. When it says guess, just press enter. Okay, again, you can see the buttons that were pushed. This arrow to the right like 15 times is where I was setting my boundaries. Okay, so you're going to keep arrowing over so you can get your boundary where you want them before you press enter. And now that we've got that in, our calculator is going to tell us the zero is at x equals 3, y equals 0. That's the point right there, 3, 0. So one of the zeros is 3. If you remember when we factored, that was one of the x values we got as well, was x equaled 3. And then we could redo these steps to set our left and right boundary over here on either side of this zero. And we do that, it will calculate that zero, and it'll tell us down here what the x value is. It gives us a y value of 0. It would come out to 7. So we could get our solutions of 3 and 7 by factoring this equation, and here we saw by graphing it, the same two solutions. It's not different solutions, it's just different methods to find those same two x values where the graph has a y value of 0. So we're going to be able to practice factoring and graphing. And we're going to do a few more examples here where I'll do these next couple by factoring, then I'll do a couple by graphing. You should be trying them as well to make sure you understand the two methods we can use. In this first example, problem number 3 there, to be able to factor this, we need to get it set equal to 0. So we need to subtract 6 on both sides. When we do that, we'll have n squared plus 5n minus 6 equals 0. So now we need to factor this. We're going to get n. Since this is a minus 6, we're going to have 1 plus and 1 minus there. Okay, it's going to be n plus 6 and n minus 1. And then when I set each of these factors equal to 0, I can get my two solutions. So n equals negative 6 and n equals 1. Those are my two solutions, which I could check by plugging that back in to the original equation. And I can take 1 and plug it back in as well, and make sure that it works. Okay. Number 4 here, this next example, again, I want to get this set equal to 0, so I'm going to subtract 3x so that I can get everything on the same side with the x squared, and I'll get 0 equals x squared minus 5x. So in this one, the factoring requires finding a greatest common factor. I'm going to have 0 equals x, and then x minus 5. When you get a problem like this, don't forget this is one of the factors. You need to set x equal to 0. Just like up here, you had two factors, n plus 6 and n minus 1. You set them each equal to 0. Down here, set each factor equal to 0. So you're going to have x equals 0 and x minus 5 equals 0. So x equals 0 is solved already. The second one, you can add 5 to both sides and get x equals 5. And now you've got your two solutions for this equation, which again, you could plug back in and check and make sure that it works. So here are the directions of it. Find the zeros. That's the same as find the solutions. Keep that in mind. Finding zeros, finding solutions, same thing. So this is already written as a y equals or f of x equals. So now we could factor it or we could graph it. I'm going to use graphing. If you use graphing, you're going to be able to enter this into the calculator as x squared plus 11x plus 18. Okay? And when you graph that, again, you're going to get a parabola that I'll sketch a little bit of what it looks like on here. You should see it exact on your calculator screen. Okay? But you're going to get a parabola that looks like this. Okay? And again, you're trying to find these points right here and right here, the zeros. So you have to set boundaries. Okay, you'll set a boundary over here on the left side and the right side for this 0, and then same thing, redo a boundary on the left side and the right side, and you'll calculate this 0. If you do that, and I'll tell you what the answer should be so you can make sure you're getting them correctly, you're going to get x equals 9 and x equals, negative 9, and x equals negative 2. So x equals negative 9 and x equals negative 2 should be the points that you get where this graph goes through the x-axis, has a y value of 0, right? That'd be like going up into the original equation saying 0 equals, right? We're trying to find out what x values do I plug in here and here that make this equation equal to 0, where there's a y value along here of 0. So practice those, get used to both methods, and know how to use graphing and factoring. Here we see another one that we want to solve. This can be a little trickier in that we need to set it equal to 0 first, so we've got to add 10 to both sides. We're going to get 0 equals negative x squared minus 3x plus 10. Don't add the 10 to the 3x or minus 3x or anything. They're not like terms. So this would be our quadratic. And now when you enter it, don't forget that negative sign in front of the x squared. When you graph it, if you don't get a parabola that's opening down, you'll know you made a mistake, right? Negative sign in front of the x squared, a negative a value means our graph's going to open down. Okay? It might look something on your screen like this. Okay? You get just a rough sketch where you're going to then be finding, again, these 2 points. And on the graph, you can press second and calculate. Okay, second and calculate, and then option 2 for a 0. You want to calculate the zeros. Then you'll set your left and right boundaries, and you'll be able to get your solution, and your answer should come out to x equals negative 5 and x equals 2. Okay, x equals negative 5 and x equals 2. If you wanted to factor this one, something to keep in mind is you'd want to factor out the negative 1, and then you have x squared plus 3x and minus 10. And then factor what you have here. So it's easier to factor without that negative sign in front of the x squared. So you can factor it out, and then you'll have this trinomial left over you can work with. Okay? You can see the trivia there. Maybe you've been thinking about it already. What's the only mammal that can fly? You're thinking, how can a mammal fly? Like cow? Cows flying? Pigs fly? That'll be the day that pigs fly, right? I mean, I don't necessarily want pigs to fly unless they're onto my plate as bacon. Okay? So here, the only mammal that can fly is a bat. So interesting fact that mammals are bats and the only ones that can fly. All right. Let's look at how we can apply what we've learned here about quadratics and solving them. Okay, so we've got a situation here where a projectile, something that's thrown in the air, kicked in the air, whatever, in the air and going to be brought down by gravity, can be modeled generally by this equation. Not a very detailed one. There's ones more exact, in physics applications, but this one generally works pretty well. Okay, so the height of something can be modeled by negative 16t squared plus vt, where v is the initial vertical velocity, and s is the starting height, s for starting height. So t is some amount of time. Okay, that's how many seconds that something's been in the air. So here we see this shot putter throws the shot put up in the air. Okay, the athlete below throws the shot put with an initial vertical velocity of 40 feet per second. So v, the initial vertical velocity, that means we're going to put the 40 in here for v. So we're going to rewrite this equation, okay, as h equals negative 16 t squared, okay, plus 40t, and then plus, what do you think we're going to put in there for the s? We're going to have an s value in there, so that's the starting height. Well, we look in our diagram here, the shot put starts at a height of 6.5 feet. If it was a ball kicked off the ground, maybe the starting height would be 0. But in this case, that starting height is 6.5. Okay, 6.5. And this is a good example of a problem where you're not really going to want to solve this one by factoring. Okay, you got that plus 6.5. I'm not sure you're going to be finding values and factors that multiply to give you 6.5, add up to 40, and here we got the negative 16t squared, so that negative 16 even makes it more complicated because we have to do the AC method, negative 16 times 6.5, and then get some factors there that we can use to get the 40. That could be pretty complicated. Okay, but what we can do is graph it. Okay, and you'll see here I entered the equation into the calculator. When you do this, you're going to enter this as a y equals. You'd put this in as your y equals negative 16x squared plus 40x plus 6.5. Okay? And so when we do that, okay, we're going to want to find the time the shot put was in the air and the maximum height. So those are two different equations. Let's talk about the first one. find the time that the shot put is in the air. Okay, so again, I entered the equation in my y equals, and then I graphed it, and here's the graph that I get. Okay, so the shot put starts 6.5, and it goes up in the air, and it comes back down, and right there, when it hits the ground, okay, that's how long it was in the air. So we're looking for that point right there. Okay, so what I want to do is calculate that. All right. So how can I calculate it? And you'll see my window here, I adjusted a little bit, right? If you do your standard window, you're not going to see everything you want. So you don't really want to put negative x and y values. We don't really care about negative x's and y's. We don't care about over here negative time or negative height when the ball is below the ground, the shot put. That doesn't make sense. Okay? And our y maximum, again, depending on what you want to enter, and our x maximum, you might have to adjust it. Here you can see 1, 2, 3, 4, 5, 6. I entered an x maximum of 6. As long as you go past here somewhere, that's fine. You might not get it exact the first time. You might graph it and go, that doesn't really work. I'm not seeing what I want. So you might have to adjust. All right? But we're looking for this point. Okay? So we can calculate that 0. This is where we might need to actually see below the graph. Okay? Because you're going to set a left boundary here, and then you have to go past this point and set your right boundary. So you could adjust your window where you see down below there, just to be able to, get your calculations done properly. Okay, so if you want to enter a y minimum that's below 0, then that makes sense for something like this. And you're going to set a left and right boundary. When you calculate, you're going to press second and calculate. Okay, right? We're pressing second and then the trace button for calculate, and you want to calculate a 0. Okay, so when you calculate the 0, again, that's option 2. And you're going to have to put a left boundary and right boundary. This would be just like what we were doing in the previous problems, calculating a 0. You're trying to calculate this point right here where the graph has a y value of 0. When it hits the ground, find the time the shot put is in the air. It's in the air until right there. Okay, so we're going to set our left and right boundary. And when we do that and get our 0, it's going to be 2.6531215, some big long decimal, y equals 0. The answer then is that x value. How long was it in the air? Well, it was in the air right to that point. That's an x value of about 2.65 seconds. Okay, so this would be about 2.65 seconds. The time the shot put is in there. X is our time in this particular example. So we're looking for an x value for that one. And then find the maximum height of the shot put. Now we're looking for this point right here. So to calculate a maximum, we press second and calculate, so the trace button. And then you'll see option 4 is maximum. You want to calculate a maximum. And you're going to have to set a left and right boundary again. This time, you're going to go on either side of that vertex. We've done this before, finding maximums and minimums. Okay? We want to find the maximum height. So we're going to set a left boundary over here, a right boundary over here, and have it calculate this point for us. Where our vertex is. Okay, so we set the left and right boundary, and we're going to see that it's x value of 1.249999, and it goes for a while. Y equals 31.5. So this point right here has a y value of 31.5. So the maximum height was 31.5 feet. Right? So we can apply these quadratic equations, and again, using factoring, graphing, know how to find those key points. Find the intercepts, find the maximums, the minimums, to be able to answer questions that go along with situations that can be modeled with quadratic functions.